Okay, so this question is from TYS, okay, 2014 paper 3, question 6. Okay, so this is part B. Okay, so two charged solid metal spheres, A and B, are situated in a vacuum. Their centers are separated by 30 cm, as illustrated by the figure. So the diagram is not to scale, of course. Okay, so next part, point P is on the line joining the centers of the two spheres. So point P is a distance x, okay? Can. So this is the graph. Okay, take note, whenever you see graph, take note of the units here, cm. Suggest why the electric field is 0 for two regions of x. In other words, they are talking about this part and this part. So why is the electric field strength 0? Okay, simply put, within a conductor, the field strength is 0. Okay, but this is already, we already know that this is within a conductor, so we cannot like write that as an answer. Okay, so the best answer probably will be something to do with the actual reason why it is 0. Okay, so that comes from understanding that the basic concept that charges reside on the surface of the they are all always on the surface of the spheres. Okay, let me just change this color to blue and then make it bigger. Okay, so charges reside on the surface of the sphere, and there are no moving charges when in equilibrium. That means the electric force is 0, and hence the electric field strength is 0. Okay? So because why? Because if there's an electric field strength, the charges will be moving. Okay, so it's not moving. There are no more moving charges. They are all residing on the surface in their own equilibrium position. So that's why there's no E field within. Okay, so use the figure to determine the radius of each sphere. Now this is pretty simple. We know that within the spheres there will be no charge. Okay, there will be no charge. There will be no E field as well. So from here, the E field 0, you can see that up to here is going to be 4 cm. So this is 4 cm. And for B, you can see that it's about 2.0 cm. Next, say I explain whether they have the charges of the same or opposite sign. The charges will be of the opposite sign. Why opposite sign? Because there is, if they are of the same sign, means both positive, both negative, there will be a neutral point. So there is no neutral point between the two spheres or the two charges between A and B. Okay, neutral point is only when they are of the same charge, when it's in between. So we can even determine which one is positive, which one is negative. So again, based on your axis, is you're actually taking the right words as positive. So we can see that the E field is positive throughout. That means that the E field is going to be in this direction. Okay, let me just draw a horizontal line. This will be the E field direction. That means that this must be positive and this must be negative. Okay, that's why you get the direction of E field from left to right. Okay, now comes the part 3. A lithium nucleus. Okay, lithium nucleus means we are just taking the 3 is 3 protons, so the charge is 3e. Okay, plus 3e. So E is the charge of the electron. Okay, proton has the same charge as the charge of the electron. So estimate the energy gain as it moves from point P, where x equals to 16, means around here, 16, to x equals to 21, which is here. Now, so you can zoom in and see that the force, the field, and hence the force is approximately constant. You're actually going to just draw a rectangle here. Okay, let me just draw. Okay, this, well, the area of this rectangle will be the work done. You can see, because the force is almost constant. Okay, because we are doing by estimate, not exact. So estimate, you'll be as good as counting the number of squares below. And at the same time, you can see that it's easy to count here because it's going to be just almost horizontal. Okay, so we'll just be counting that. Okay, let me just shade here. Okay, okay, I think I'll just just leave the rectangle there. Okay, so you can see that force is approximately constant. Force is QE. Q is 3 times the charge of electron, okay, which 1.6 times 10 power minus 19. And E field, read off from here, you can see that this is going to be just, it's actually 2 divided by 5 times, 2 divided by 5 times 3, here is 1.2, here is going to be 1.2. So 1.2, remember this times 10 power 5, okay? So F equals to QE equals to 3E times 1.2 times 10 power 5. Okay, so this will give us, let me just press the calculator. 3 times 1.6 times 10 power minus 19 times 1.2 times 10 power 5. You get around 5.76 times 10 to the power of negative 14 Newton. Okay, so distance moved is equals to 21 minus 16. You'll get 5.0 cm. So energy gain is approximately force times distance. So 5.76 times 10 power minus 14 times 5.0 over 100. Okay, so we are doing by SI unit times 5 divided by 100. You'll get 2.88. Oops. 2.88 times 10 to the power of negative 15 joules. Okay, so that will be the answer. Okay, so why is it 5 marks? Probably, my guess, the first part, the force probably is probably 2 marks, 2 marks or 3 marks. Okay, reading of the graph definitely some marks. Okay, next part, calculate the acceleration where x equals to 25 cm. Okay, this is simple. So when x equals to 25 cm, you just need to find the E field, which is here. Okay, and you can read off that this is between 2.0 and 4.0. So this is exactly 3.0 times 10 power 5. Okay, so E field at this point is 3.0 times 10 to the power of 5 volts per meter. So acceleration is actually force over mass. Okay, force is going to be QE, so 3 of charge of electron times the electric field strength divided by the mass. Now the mass is due to 7, okay, 7 nuclei. So how you understand the 7 is actually in the chapter of nuclear physics. So anyway, I'll just put it as here 7U, where U is the unified atomic mass. Okay, now if you want to do your molar mass and then calculate accordingly, go ahead, but just that you'll probably take a bit longer. Okay, so from here we can just calculate. Okay, let me just type into the calculator. Divided by 7 u, 1.66 times 10 power minus 27. U is a constant that's given in the list of constants. Okay, it's called a unified atomic mass. So you should get 1.24 times 10 power 13 meters per second squared. Okay, it's a pretty large number, which is quite common for E field. Okay, U, again, this charge of electron, this unified atomic mass, both are list of constants that you can get from, both are constants that you can get from the list of constants given to you. So last part, the nucleus is at rest at point P where x goes to 4 cm. So if you look at the graph at 4 cm, you're actually right at the surface of sphere A. Okay, so describe qualitatively what happens to the acceleration. Okay, so 3 marks means there must be 3 points, and you can see that this is actually a giveaway question here. Okay, why? Because you can see that the first part here, the E field, because F equals to QE, so the E field decreases. That means that the force decreases. Okay, and here the force will increase because the E field increase. So there's a decrease, there's an increase, but it's 3 marks. So definitely you will need to talk about 3 points. Okay, so this one is 1 point, this one is 1 point. The last point will likely be at somewhere here. Okay, we will probably need to say where is the bottom. Okay, I will choose this place as the bottom. A bit hard to choose in between. So this place is 16, 17, 18.5. So 18.5 will be where the force, the E field, and hence the force, and hence the acceleration being the smallest point. So I believe this will be the third mark. Okay, no calculations needed, qualitative. So how to tackle your answer? Okay, so from this one is more, this as explanation question is more of the type of story based. Okay, so you need to type your sequence of events again. From x equals 4.0 cm to 18.5 cm. Okay, recognition of 18.5 is probably 1 mark already. The acceleration of the nucleus decreases. Nucleus decreases from x equals or maybe at x equals 18.5 cm. The acceleration is at its lowest value or lowest magnitude. At x equals from x equals 18.5. Now we go to the last part to 28 cm. The acceleration of the nucleus increases. Okay, because the E field increases. Okay, they are only asking for the acceleration. So throughout the point, throughout the entire motion, okay, the acceleration is always positive. So it will keep accelerating. It will still, the speed will keep increasing.